Introduction to Writing and Balancing Chemical Equations. This topic can also be called stoichiometry. So in this video, I'm going to talk about how to write a chemical equation from a description of the reaction. I'm going to talk about the difference between an unbalanced equation and a balanced equation. And I'm going to talk about how to balance an unbalanced equation, the steps you need to go through in order to get that balanced equation at the end. So I have a sentence describing a chemical reaction. Methane and oxygen react to make carbon dioxide and water. I can rewrite this sentence directly into an unbalanced equation. An unbalanced equation has the exact same information as this sentence. So methane, its molecular formula is CH4, one carbon atom bonded to 4 hydrogens. And oxygen. Oxygen in its most common form is actually 2 oxygen atoms bonded to each other, so O2. React to make. I am representing the reaction itself as an arrow. So this arrow is the chemical reaction. And our products are carbon dioxide and water. Carbon dioxide is CO2, a carbon atom bonded to 2 oxygens, and water. Water is 2 hydrogens bonded to an oxygen. Now the reason that this is called an unbalanced equation is because there is a problem with it. In the real world, during a chemical reaction, atoms are rearranged. They are not created, they are not destroyed. We need the same number of atoms of each element before a reaction and after. So an unbalanced equation tells you what your reactants are. Reactants are your starting materials. It tells you what your products are, but it does not tell you what ratio they are in. So a balanced equation is going to have possibly different numbers of each of these molecules, such that you do have the same number of atoms of each element before and after the reaction. The definition of balanced equation has the same number of atoms of each element before and after the reaction. So before the arrow and after the arrow. We are not creating nor destroying any atoms. Atoms are neither created nor destroyed. So you can rearrange atoms, you cannot make them appear nor disappear. So let me redraw this unbalanced equation in pictures of the molecules. So methane is a carbon in the center bonded to 4 hydrogen atoms. Oxygen, O2, is 2 oxygen atoms double bonded to each other. During the reaction, we are making carbon dioxide. Carbon dioxide. Carbon is in the center, double bonded to 2 different oxygen atoms. And water. For water, oxygen is in the center, bonded to 2 hydrogens. Now, don't worry if you can't draw the structures right now. This is about demonstrating the importance of balancing a reaction. But let's count how many atoms of each element we have before the reaction and after. So carbon, before the reaction, we have 1 carbon atom. After the reaction, 1 carbon atom. Carbon is good. Next, let's look at hydrogen. Before the reaction, we have a total of 4 hydrogen atoms. 1, 2, 3, 4. Afterwards, we only have 2. 1, 2. That's a problem. We want the same number of atoms of each element before the reaction and after. So I'm going to add a second molecule of water. Okay? Because with 2 molecules of water, each having 2 hydrogens, we now have a total of 4 hydrogen atoms. Hydrogen is now accounted for. Next, let's look at oxygen. Before the reaction, 2 oxygen atoms. after the reaction, we have a total of 4. Carbon dioxide has 2 oxygens. We have 2 molecules of water, each with 1. That is 4 oxygens. So in order to balance in terms of oxygen, we need 2 of these oxygen molecules. So at this point in time, everything is accounted for. We have the same number of atoms of each element before the reaction versus after. Notice what I did to accomplish this. I could add more molecules. I could not add just individual atoms. I had to take the reactants and the products, and I could multiply them by some whole number. I could say we have 2 molecules now instead of 1, but it is always going to be the whole molecule. So a balanced equation, we are going to put numbers in front of the oxygen and in front of the water to tell us that there is more than one of them. So in a balanced equation, we still have 1 molecule of methane, CH4, but it is going to react with 2 molecules of oxygen, 2 O2. This reacts to make 1 molecule of carbon dioxide, CO2, and 2 molecules of water. So this is how you write a balanced equation. So notice a couple of details. We have 1 molecule of methane reacting with 2 molecules of oxygen to make 1 molecule of carbon dioxide, 2 molecules of water. Notice that I only wrote 2's for the oxygen and the water. Typically, when there is 1 of a certain molecule, 1 molecule of methane, 1 molecule of carbon dioxide, people don't bother to write the number 1. If you do not see a coefficient written, that implies that it's 1. Another important detail is that these coefficients need to be the smallest possible whole numbers. So you could have mathematically figured out that your coefficients should have been 2, 4, 2, 4. This is wrong. Think of reducing a fraction. If you have a fraction of 2 over 4, both of these numbers can be divided by 2. You can reduce the fraction to 1 over 2. It is that same sort of concept. You need the smallest possible whole numbers. And again, similar example, you do not want 0.51, 0.51. There is only going to be 1 correct answer for what these coefficients are, and that is their smallest possible whole numbers. So I want to show the same chemical reaction over again, but using molecular models. So on the left, we have a model of methane. There's a black carbon bonded to 4 yellow hydrogens. On the right, we have 2 diatomic oxygens. Diatomic means 2 atoms, so 2 oxygen atoms bonded to each other. Now, this is the ratio in which methane and oxygen react. That means I should be able to take apart these molecular models and rearrange all of the atoms to make our products in their proper ratio. I should be able to make 1 molecule of carbon dioxide and 2 molecules of water. So everything is taken apart. Chemical reaction is in progress. I'm going to start by making a molecule of carbon dioxide. So I have the black carbon atom. I need to bond this to 2 red oxygens. So this is carbon dioxide, oxygen, carbon, oxygen. I'm going to make 2 water molecules, red oxygen in the center, each bonded to 2 yellow hydrogens. So I was able to make 1 molecule of carbon dioxide, 2 molecules of water. In the next video, we are going to be practicing balancing chemical equations. So we are going to start off each time with an unbalanced equation. We are going to work to balance them. And throughout the video, the problems are going to get progressively more difficult. By the time we get to the end of the video, you are going to see me introduce a new method, an algebraic method, so that we can solve extremely difficult problems that way.